All right, good evening, I guess, everyone. Welcome to our first debate of this conference, I guess, yeah. Our debate topic is oxygen the primary determinant in the flash effect? My name is Michelle Kim, and my co-chair, Pierre Montegruel, and I will be moderating this debate. We will have 4 speakers, each discussing their points, either for or against this notion. At the end, we will have a live discussion for about 5 minutes, and there will be a voting period where please follow the instructions that will be on the screen. Through the app, you will be able to vote either yes or no, and at the end, we'll display the results, and hopefully we'll have some nice discussion after that as well. So to start, I would like to welcome Bethany Rothwell to the stage to give us the first for argument for this case.
Okay. Thank you. So it looks like Marco and I have the job of convincing you all that oxygen is important. Hopefully it's not too unpopular an opinion. But in this sort of brief talk, I'm just going to give sort of 3 key reasons why oxygen is important for flash. So my first point, which Marco is going to expand upon, is that flash is an oxygen-dependent process. There's a lot of things we don't know about flash, but this is not what we know this. We've got the data, we've got in vivo and vitro data, we've got proof that oxygen really influences the flash effect. We've all seen this study by Pierre Montegruel et al. Showing how when you add oxygen, it reverses the flash effect in terms of its sparing on neurocognitive functions in mice. There's also been similar studies by the University of Texas, MD Anderson, who've also shown that by adding oxygen, you decrease the flash effect. So we can see that in vivo. In vitro, again, lots of studies. I think Marco's going to show some of the stuff that they've been doing. But this is just a really good example of how the oxygen conditions really influence whether or not we get a flash effect. This is comet assay results from Cooper et al., who found that there's a clear oxygen dependence of the flash effect, and they found that an oxygen level of about 1% oxygen is needed to see the flash effect in vitro. And not just for healthy tissue as well. Again, the Lausanne group have got this really great study looking at oxygen effect in tumours, and they showed with conventional irradiation that when we use clamping to restrict the blood flow, we get this sort of reduction in anti-tumour efficacy again, but that when we use flash, we get the same effect. So implying there that in hypoxia, flash could actually have better tumour control than conventional radiation, but in hypoxia, when our oxygen levels are correct. So we've got in vitro data and vivo data. Like I say, Marco is going to sort of bombard you with more information, hopefully convince you that flash is an oxygen-dependent effect. My second point is that oxygen is important no matter what. So there's a lot of debate about the mechanism for flash. We've got a lot of really good long-standing theories. We've heard some really great new ones. But the one thing that they all have in common is that they're all to do with oxygen. So for example, does anyone think that, oxygen depletion explains flash? Well, if yes, then yes, that's definitely an effect where oxygen is important. If not, what about radical recombination? Well, if by this we're talking about the sort of recombination of radicals in a greater proportion than those which react with oxygen to go and cause indirect damage, then yes, oxygen's important there as well. You need that oxygen levels right to get that maximum sparing effect. If not, what about the ability, the sort of differential ability of normal tissue to detoxify, to convert, to get rid of hydroperoxides better than tumour? Again, we need the oxygen to convert those hydroperoxides anyway, so yes, that's also an oxygen-dependent process. And you might be thinking, what about immune effects? But oxygen fuels the immune system, right? Oxygen levels have been shown to influence T-cell persistence, immunoradiotherapeutic efficacy. So yes, oxygen is important there as well. Even if it's none of these mechanisms, right? We don't really know. Are you currently alive? Are you breathing right now? If the answer is yes, I'm sorry to tell you, but oxygen is important. If not, the only thing I can really ask there is, will you be donating your body to flash research? Of course, it won't be very useful because, you guessed it, you're not breathing oxygen. So hopefully that's convinced you there that oxygen is important. My final point, as I'm trying to sort of guess what, the opponents are going to argue here. Like, surely, yes, oxygen might be important, but surely it's the dose rate, right? For flash, dose rate is what everyone cares about. My argument would be, sure, we need high dose rates to access the flash effect, but oxygen is what determines it, what drives it. Does anyone here keep up with Formula One? Show of hands. Yeah, okay, a couple people. So it's like sport, but for nerds, right? Like, it's great. The thing about Formula One car racing, right? Having a fast car is a given, right? Everyone's got a fast car. You have to have a fast car just to even be considered into the race. It's not the speed of the car that really makes the difference at the top level, right? You've got the drivers, the conditions, all these things that actually make the race interesting. I could get in the fastest car in the world. That doesn't mean I'm going to secure the top spot in Formula One. And so that's kind of like flash, right? We need these high dose rates, sure, but once we're above a certain level, 40 gray per second, 100, whatever our threshold is, once we're there, it's really these other effects, oxygen most consistently shown to have the influence. So, in this example here, Max Verstappen and Sergio Perez, they both drive pretty much the same car. But Max Verstappen is what happens when you get your oxygen conditions right, and he is the winner. So just to summarize, flash is an oxygen-dependent process. We'll hear more about that. Oxygen is important no matter what. We don't know the mechanism, but oxygen's doing something. And high dose rates are used to access the flash effect. Sure, oxygen drives it. So I'll hand over to Marco now. Thank you.
Next up, we have Marco Durante, also arguing for the for side of this debate.
So, she made my life easy because, of course, now you have seen pretty much the same thing that I wanted to show you, but it's good to repeat. First of all, I want to say I have to thank Emanuele Schifoni, who I hope is in the room for support. I had a long discussion. He's a chemist. I'm a physicist. And as everybody knows, physicists think that they understand everything. But in reality, when we go to chemistry, it's better speak to chemists. So he was really helpful. Thank you, Emanuele. So, okay. Before my opponents say that, I'm not claiming that necessarily flash is due to oxygen depletion. I cannot even do it because actually I have a paper with Emanuele that seems to show that oxygen depletion is not sufficient to explain the flash effect. And I think Jeannette Jansen, she will show some experimental data in this same direction. So before she goes, I want to say it myself. But how can we deny that oxygen has a key role? I think already Bethany gave a lot of arguments. So we start with in vitro. In vitro, we have this plot is exactly the same that she showed, but this is a very nice paper from Adrian and co-workers. And these are very old data. These are data from 1974 and 1978. Showing exactly that you see the flash effect only when you are in condition of moderate hypoxia. So it's something that we know since 50 years. It's certainly not the big news. Of course we know that oxygen is essential. We know it since 50 years. These are actually data from my own group at GSI. This is in collaboration with Heidelberg, with HIT. We also measured with carbon ions this time cell killing, and you see that when you are in total anoxia or in total oxic conditions, you don't see any difference. But when you are in moderate hypoxia, you see the data here, 0.5% and 4%, you do see a difference in cell killing, even with carbon ions, not only with electrons or photons. So, and then in vivo, of course, this Pierre is the chair there. I'm sure he will support us because we always show his data. So this is very convincing. But these are also data, very nice data from Jörg Pavelka and his group in Dresden in zebrafish, again showing clearly that the oxygen pressure matters and that you see the flash effect essentially magnified, possible only when you have a low oxygen condition. Then the models. Okay, so we have the data. If you say that oxygen is not important, you have to deny 50 years of experimental data. But then you say, yeah, but you know, there is a complicated mechanism that can show that this is the way. All the models that we have, all of them, almost all of them, point clearly on oxygen. This one of my favorite is the one by Rudy Labarbe and co-workers. Well, it's not based on transient oxygen depletion, but is based on oxygen radicals again, and the formation of oxygen radicals. And you see, this is a statement from the paper. The model from this paper, the model explains the NTCP dependence on O2. The model does not lend weight to the hypothesis of transient oxygen depletion, but still there is a major role of radical-radical recombination that are oxygen. So I think it's clear. You can also look at review papers that are found. I mean, there is this paper I want to advertise because I'm very proud of it, because we made, with Marika Tren and Jamboree, we did the cover of Nature Reviews Clinical Oncology, and you can find a lot. But the best paper, the best review on the importance of oxygen is actually this one. It's a very nice paper from 2020 from Vincent Favaudon, Rudy Labarbe again, and Charlie Di Moli. I wanted to tease my friend Charlie Di Moli here because he was supposed to argue against, but this paper is clearly for. Unfortunately, Charlie is not here, but if he's online, I take the opportunity to send my best regards and best wishes for a prompt recovery. So, in conclusion, all experiment results support a decisive role of oxygen or its lack thereof in the flash effect, all of them. Almost all theoretical models postulate a primary determinant role of oxygen. So if it is not oxygen, then what? I mean, I tried to put myself in the shoes of my opponents, and I came with three theories. I mean, one is the hand of God, one is alien intervention, and the third one is the flesh itself that comes and solves the problem. I mean, clearly, it's very hard to deny the amount of evidence that we have. The alternative hypotheses are not so convincing, let's put it this way. And with this, I want to thank all of you, and please support oxygen, because despite what is written here, as Bethany showed, is very important. Thank you.
Thank you to both of you. We are now going against the motion with Jeannette, Jansen and João Seco from Heidelberg. You have 10 minutes to show us that oxygen doesn't matter.
All right, so welcome everybody, and thanks for participating in this wonderful debate. I will make it very quick and say, is oxygen a primary determinant in the flash effect? Clear no. As you can see, Grand Picat also supports that. But I want to stress a little bit further that we have to discriminate between two different aspects when it comes to oxygen. First of all, we have to talk about oxygen depletion, and second, we have to talk about the radicals that are produced by oxygen. And then I come to the question which I think my opponents have let's put a bit under the table, which is if it's primary. I think they have not really addressed that point. And then I want to always distinguish between the flash effect in terms of whether it's a differential effect between healthy tissue and tumor tissue, or if we consider an effect within the same tissue or water, which would be then basically, for example, explaining a protective effect of healthy tissue. So first of all, why do we care about oxygen? Well, I think we know all that we have, do I see the pointer? Yes. We have different O2 levels in tumor and healthy tissue. So tumor has usually around 1.4%, healthy tissue around 6%, plus minus. It's a huge duration. And this brings us to different radiosensitivity levels. I think we all know that. And from all this, the oxygen depletion hypothesis occurred that we would induce a change in oxygen based on radiation. And we have done this study where we wanted to measure the oxygen depletion as a function of dose rate. And in order to explain flash effects with oxygen, you would have to come to the conclusion that you would have either the same depletion of O2 at flash dose rates or more depletion at flash dose rates. And what we found was basically that we have less depletion in flash dose rates. And the study, so there was other studies as well, for example, this one from Mina El-Kadib from this year, where they also measured O2 depletion as a function of dose rate. And what they found, interestingly, was also that there was less depletion at flash dose rate. This was not in water, but in BSA. And also they found that the step size here got slower. What does it mean? This means for low oxygen levels, we have a lower depletion. And I want to stress that because I will come to this point again later when we discuss the differential effect. We have repeated the study as well, and we come to the same conclusion. We have less depletion in flash dose rates and also less depletion for low oxygen. Again, this is very important here. So this can explain a bit the same tissue thingies. Now I come a bit to differential effects. This was a nice study from Shukao et al. From Brian Polk's lab. I think you all know that one. In here, they also did some measurements in BSA and also found less depletion at flash. So this is, I think, what we can really agree on. However, you don't see it when you do the studies in mice because we have cardiovascular systems. So you would have a reoxygenation of the tissue while you have a depletion. So we want to check here now the flash side, the left-hand side. And interestingly, what you could see here, there was the normal tissue versus the tumor tissue comparison. And they found that you had a lower depletion in the tumor. So key point here, in tumor we have less depletion. Also keep it in mind, it becomes important later. So I want to ask not if oxygen is the primary determinant effect, but is oxygen depletion the primary determinant in the flash effect? And I can clearly say it's not primary because there should be a great change in that case, and we don't see it. We only see a small change in depletion. We only see a small change in oxygen for 10 gray, for example, which does not make any sense to translate that to some clinical conditions. For example, when we have 10 gray radiation, we only reduce O2 by such a small amount that radiation-induced hypoxia cannot really play a role. Also, we see less depletion in flash. So now I want to talk about the oxygen radicals. I have this overview of Mirna's paper again, and I want to address these two nice little radicals here that are produced very early in radiation, so the electrons and the protons, and they are our key players when it comes to any radiation-induced change in oxygen levels, let's say, because O2 will react with these two to form superoxide, and then we have many cascades going on, and in non-water systems, but like biological systems, you will also have peroxides and so on. And what we have observed is higher depletion at low dose rates. So this would mean we have potentially more radicals to react with O2 because you need that to actually reduce oxygen. But would this mean that we have more damage? I think yes, this makes sense. And this in the end can explain why we have within the same tissue, for example, in our healthy tissue, why we have a protective effect. This means we have, for example, high dose rates, so we have less depletion, less radicals, less damage. I'm happy. This is wonderful. What does it mean now in the biological systems? We have a different amount of radicals present. That means we get a different amount of DNA damages, different amount of lipid peroxidation, and so on and so forth. And also, like Huda has pointed out yesterday in a wonderful talk, that you can actually also have changes in the H2O2 level, which is also very important when we deal with DNA damage. So for our healthy tissue protection effect, oxygen is clearly important, but when we think this through and come to the final conclusion, what happens at the differential effect, this whole thing becomes a little bit problematic, I feel, because what we observe is that we have more depletion at high oxygen, as I pointed out earlier. But what that does mean? Our healthy tissue has typically a higher O2 level. If we now take the same argument and say, this means we produce more radicals in the healthy tissue, this doesn't make any sense. So when we think of oxygen as the primary determinant, we run into a big problem for the differential effect. And we cannot really explain this one here. So when I ask, is oxygen the primary determinant in the flash effect, I would say this means that oxygen should be the primary determinant or the primary difference between tumor and healthy tissue, which I would highly doubt. And for that reason, I would like to rephrase the question and ask, is oxygen content actually a primary difference between healthy and tumor tissue? And I want to ask you, so who in the audience thinks that O2 levels are not the primary differences between healthy and tumor tissue? Hands up, please. Who thinks oxygen levels are not the primary difference between healthy and tumor tissue? I see quite some hands up. This is very nice. I'm happy. So the question for Flash is, what else? What else can it be then if it's not oxygen as a primary determinant? And here I would like to hand over to João when it comes to some other mechanisms that could explain it when it's not oxygen.
So technically I'm replacing Charlie, so I'm the younger version of Charlie, so hopefully you can see and understand that. I was given this task as the younger person yesterday, so I tried my best to put together some of Charlie's slides. I've adapted one of his slides, I've told him already, but all the credit goes to Charlie, first of all. So I see you've already seen the slides, probably some of you have seen it more than once, and you immediately see that the implausible mechanism somewhere in the middle there is oxygen depletion. So I'm going to insist on this idea that Jeannette was showing, right? Healthy tissue have higher oxygen, yet all the famous studies that started in 2014 show that healthy tissue is protected, while the tumor has lower oxygen and it was not affected by flash. So there is a difference between oxygen damage and flash effect. And this is something I already discussed the other day. Oxygen damage depends on oxygen, and that's one thing. Flash effects depends on a differential effect between healthy tissue and cancer. So I'm going to insist again. So Charlie presented a really nice slide some months ago, and I copied it. So oxygen depletion is not the differential effect, but oxygen is important to damage. Okay, and of course this is. Oops, sorry, went the other way. There's a variety of mechanisms. I'm not going to insist in any one of them specifically. At the moment, we can say that it's still an open debate to see which one is better, and there's a need for experimental data. But please understand that the tissue has more oxygen, the healthy tissue has more oxygen. Why is it then suddenly flash protected? It's true. Pierre's studies from several years back with the carbogen have shown that if you change that oxygen, you do affect the differential effect. But keep in mind, what matters is the tissue, the healthy tissue with oxygen is the one that's been protected with flash and not the cancer. All right, and I will stop there and we'll go forward with the voting, I think. Thank you very much.
All right, so at this time, if everyone could open up their apps and go to the discussion. Sorry. Not yet. We're going to do the live discussion. I'm sorry. So if anyone has any comments, please come up to the microphone and we can get this discussion started with all of you.
Who wants to challenge them? Nobody? Not even MCAT? She's been asking too many questions.
Let's go for it.
Okay.
Well, if it's not oxygen, then what it is? Jeannette?
Okay, yeah, maybe I can comment on that. Marcus says it's the hand of God, okay? If it's not oxygen, what is it instead? I found the results that we got on the conference quite interesting that we saw yesterday by Pascal Freudevaux regarding lipid peroxidations, which seemed to show a very big difference when you have flash versus conventional radiation. And then also he mentioned that we would have probably quite different levels of fatty acids in tumor and healthy tissue. So I think this is a very interesting thing to follow up on. And also ferroptosis maybe might play some role. So I think in the end, probably it's more about some differences between healthy and tumor tissue and not so much about oxygen. Oxygen is a side effect that is for sure there. I'm not saying it's not important, but it's probably not the most important thing.
So do we have to throw out the chemist?
At least a few physicists should learn some chemistry first.
In fact, I did my best. I asked around, let's say, but honestly, you did a fantastic job, of course, both of you. But my impression is that you convincingly demonstrated that it's not oxygen depletion. You did not demonstrate that oxygen is not the most important factor, the determinant factor. That's the problem. Yes, okay, I think everybody has doubts about the initial oxygen depletion hypothesis, and you have a lot of data showing that it doesn't hold. But still, every time you answer, you say, then what it is? Oh, maybe peroxidation. Oxidation. So there is always the oxygen involved, you know.
Yeah, exactly what I was going to say. The clue is in the name. Every other mechanism we've suggested, oxygen is involved in some way. And like Marco says, the name of the debate is oxygen depletion the primary determinant of the flash effects? Is oxygen the primary determinant? So again, great slides. I agree. Oxygen depletion probably isn't the primary determinant of the flash effect, but oxygen is.
I want to disagree. I think Pierre's results have shown exactly the opposite. In both cases, with and without carbogen, there was a flash protection of the healthy tissue, but not of the tumor. So yes, oxygen is important for damage, and how much damage depends on oxygen, but we still need to figure out this differential effect, which is the fun part, and maybe we hear other comments.
Okay, so a question for the pro team, okay? I totally get your point. You know, you totally explained that it's not oxygen depletion, and you were actually arguing that we should think only about oxygen. So I have a question there. Considering that the flash effect was observed in so many various tissues that have so many different oxygenation levels, how would you explain that and still claim that oxygen is the main determinant?
Thank you.
Now we're becoming unfair with this clapping. Then I will ask my friends to clap their hands. So we have to play fair here. Eh? So do you want to answer this one? I think that the answer is that who say that the flash effect is the same in every tissue? It is not. So we cannot rule out that even the difference that we see in different tissues, and we see a difference among the different tissues, is related to the oxygen content, which, by the way, as everybody knows, is not 20% in the normal tissue. Is always lower. The physioxia, let's say, is always substantially lower than 20%.
If anyone has a data set showing levels of flash sparing and the oxygen level, a full data set for all the flash results, and you can convince us that there's no pattern to do with flash sparing related to oxygen, then maybe, yeah, I would agree. But also I would just say that, yes, flash sparing has been observed when we haven't done anything to change the oxygen, and sure, Pierre saw that adding oxygen reversed the flash effect. But that doesn't, just because the prerequisite is already met, it doesn't mean the prerequisite isn't already there. Maybe normal oxygen conditions are what's needed to cause a flash effect, but that doesn't mean flash isn't determined by it. So
Maybe we also have to think about if we really think of the oxygen itself as a molecule, or whether we think of how the tumor tissue and the healthy tissue, in which statuses they are when they have a certain oxygen level. Maybe they have different levels of antioxidants, scavengers, whatever, which is then actually driving the whole effect. And then O2 might be the initial starting point, but not the actual reason. It might be just...
You said again antioxidant.
keep saying oxygen.
I'm not claiming oxygen is not important.
But the good thing is that antioxidants are not related to oxygen, but the oxidizing capacity of it. So this is a completely different situation, right?
I keep hearing oxygen from my opponent.
Scavengers.
Scavenger of oxygen.
In the first meeting we made, it was oxygen, oxygen. In the second was radicals, radicals. In this one is lipids, lipids. It seems that oxygen role is going far in the chain, not at the very beginning, but much more on the natural oxygen in tissues and in living material. I think that over radiation, we are making suffering those cells too much when we extract the oxygen, when we put more oxygen, that we're affecting the natural process of that. So maybe I should strongly support oxygen, yes, but not the primary reason.
But you know, the problem that I see if you deny that oxygen is primary, there are 50 years of data that you essentially put in the trash. I mean, where essentially you have the same conditions, you only change oxygen concentration, only oxygen concentration, and you find, in one case you find flash, in the other case you don't find flash. So it's... I think it's very, very difficult at this point to say flash is not the most important. I mean, when you have this, I'm a physicist, no? And in physics we say when you have a huge amount of data, when you have the Newton's law, when you have thermodynamics, no, you can change everything in physics, but not thermodynamics. No, thermodynamics is, if your experiment goes against thermodynamics law, then repeat the experiment.
I think that there is a lot of thermodynamics, but in the cell level. But the experiments 50 years ago were with bacteria and 200 kilorats. We cannot compare that with tissue today and flash.
But there are experiments done last year.
Yeah, this is basically, again, the question whether we consider the differential effect or the effect on the same tissue. So when we just have the cell experiments from the 50s, then it's basically the same tissue comparison, but not the healthy versus the tumorous tissue. So I really think this is the key where we have to focus the research on. Not so much on the same tissue or like cells and so on, but really on the differential effect.
Maybe the next meeting will focus on the hand of God idea, because I think this is really out of the box, and I think we're just progressing through all the different proteins, and that one is the one that's missing, I think. So maybe, but anyway, I'm still...
That's a good one.
Maybe the next meeting will be around ferroptosis. I don't know. Let's see.
Yeah, but still, once again, whatever you propose, you have to explain this data. You have to say, oh, and then this explain this data. So this is my point. You know, at the end, the data are so many, so clear that you have to find a way to explain it.
I think it's like a Formula One car. I think if you change one part of the car, then suddenly the other part has to change. And it's become so non-linear that I really never sometimes find a single solution. And as a physicist, I like one simple solution, but I've learned with biology, there is no one solution for everything. It's a nightmare. So oxygen influences everything, but I'm still against it, sorry.
Oxygen influences everything, and we don't know what's causing flash, so oxygen's going to be to do with it. We don't know. We can't rule it out because we don't know why flash happens exactly, but we know it's going to be affecting something.
Who is aware in this assistance of a protein of the Phoenipol-Landau system, which is known as IF1 alpha, and is involved in the activation of the group of genes, which is known as the hypoxia response element? Who? That's wonderful, yeah. Because it is involved, okay, in the response to hypoxia, but mild hypoxia, not only deep hypoxia. And it has a radioprotecting effect, which is very large. And it explains, for the most part, the difference in the survival curves in equilibrium with air or in absence of oxygen. And the difference is a factor of 3. So it should be taken into consideration. We are telling about the oxygen effect.
Yeah, I think that's a very nice comment, because together with HIV, we also have changes in DNA repair capacities and so on and so forth. So this really will play a big role, also in the flash, I guess, yeah.
One of many ways that oxygen affects things.
Okay, so now is the time for everybody to open their apps. If we could get the instructions back up, please. Thank you. Everyone online can also participate in the vote. Please take a few moments and vote on whether you believe is oxygen the primary determinant in the flash effect.
There's a lot of updates, you know. This is
That's close.
Oh, that's
So,
very close.
I look forward to an oxygenated drink then. Thank you very much. Thank you so much. Your presentation was super. Well done.
So I guess congratulations to the team who was against, and Jeannette, you did an amazing job. João is telling me to emphasize your role there. Congratulations to the 4 speakers. It was very tight, 48-52%. I think that proves that we just don't agree on on this. It might be the hand of God, if I remember well. I think Charlie also mentioned God last year in the debate, so the people who will debate next year, please don't forget to mention God. We might find a solution there for the mechanisms of flash. whatever you think it is, if you think that oxygen is important no matter what, that it's not only just oxygen depletion, but all models point to the oxygen no matter what, that maybe it's the hand of gods, maybe it's aliens, maybe it's the flash itself, or that since there is less oxygen depletion after flash, it cannot completely explain the flash effect. If you think that oxygen is important for damage, but not for the differential effect of flash between normal tissue and cancer, whatever are your thoughts about that, we are looking forward to see your results next year in Toronto about the oxygen hypothesis. I think we will not forget about oxygen in the field, at least for the upcoming years. Thank you very much to all of you, to the people who participated to the debate. The 4 of you were amazing. Thank you for voting. And now I think it's a bit of time around the history of flash. So we'll all listen to this very interesting talk. Thank you very much.